let's dive right into one of the biggest debates in the data world. It's a question of structure, of philosophy, really. It's the classic showdown, the elegant, organized star schema versus the brutally simple flat table.
But let's start with the feeling. A feeling I bet a lot of you know all too well. Your company's data is exploding, right? It's coming from everywhere. But then, when you need an answer, you hit run on that query, and you just wait. If that sounds familiar, then you're gonna want to stick around. Because here's the deal. The game has totally changed. We're way past the era of slow overnight reports. Businesses today need insights on the fly, to understand their customers, to see what's coming next. And they need those answers right now, from data sets that are just getting bigger and bigger every single day.
So here's how we're going to break it all down. First, we'll talk about this modern data challenge. Then we'll get into the main event, star schema versus flat table. After that, we'll look at a study that put them head-to-head on modern cloud databases, peek under the hood at the tech that makes it all possible, and finally wrap up with what this all means for you. Let's do it.
You see, this new need for speed at a massive scale demanded a whole new breed of database. The old-school systems just couldn't hang. And this pressure created a big bang of innovation, especially in the cloud.
And here they are, the titans of this new era. You know the names: Snowflake, Redshift, BigQuery. These are cloud-native platforms built from the ground up for huge analytical workloads. They completely changed the game, but they also left us with a really important question. Do the old rules of data modeling still apply?
And that question brings us right to the heart of our debate. For decades, there was pretty much one right way to build a data warehouse. But the raw power of these new cloud systems has thrown all that old wisdom into doubt.
So first up, we've got the reigning champion, the star schema. You've got a fact table right in the middle. This holds your key business events, like sales transactions. And orbiting around it are your dimension tables, giving you all the context, the who, what, where, and when for every single fact. It's clean, it's organized.
And in the other corner, you have the challenger, the flat table. You might hear it called one big table. And the philosophy here is just radical simplicity. Forget all those different tables and connections. You just take everything you need, the sales figure, the customer's name, the product description, the date, and you smash it all together into one single, gigantic, wide table. The big selling point? No joins required. So here's the classic trade-off. The star schema is super efficient. You only store a customer's name once, which saves a ton of space and keeps your data consistent. The downside? You're always joining tables to get the full picture. The flat table is the exact opposite. Your queries are dead simple, no joins, but you pay for it with massive data redundancy, repeating the same information over and over and over again, which can make that one table absolutely enormous.
And this really captures the industry's mindset for a very long time. This quote nails it. The star schema wasn't just a technical preference, it was seen as the correct way to model a business. It provides structure, it's reusable, it's logical. For years, this was pretty much settled law in the data world.
But what happens when you take those old, settled laws and you stress test them on brand new technology? Well, it's time to move past the theory and see what the data actually tells us.
So, we're going to dig into a performance study where researchers did exactly that. They took the same complex analytical queries and ran them against both star schemas and flat tables on a bunch of popular cloud data warehouses. They were only measuring one thing: pure, raw speed. And let me tell you, the results were not what the old textbooks would have led you to believe.
And the big reveal? There was no single winner. It's complicated. For the big columnar databases, the results were split. On Amazon Redshift, the good old star schema was actually faster. But on IBM's database, the flat table came out on top. And for the really new SQL systems, the ones designed to handle everything at once, the flat table was the undisputed champion. The old rule that joins are always slow was officially busted.
And just look at this chart. This shows the most jaw-dropping result from the study. On SingleStore, which is one of those new SQL databases, the flat table wasn't just a little faster. It was insanely faster. We're talking a massive night-and-day performance difference. This is hard proof that for some modern systems, avoiding those joins gives you a huge speed boost.
But, and this is a huge but, there's a price to pay. The study found that when you go with a flat table, your total data volume explodes by 4 to 5 times on average. All that duplicated information really adds up. So yeah, your queries might fly, but your cloud storage bill is going to fly right up there with it. And that's the core tension right there. Do you optimize for query speed or for storage cost?
So why is this happening? How are these new databases completely rewriting the rules we thought we knew?
To get that, we need to pop the hood and look at the engine that's powering all of this.
Okay, so a lot of these systems use an architecture called massively parallel processing, or MPP. Think of it like this. Your query first goes to a leader node. The leader is the project manager. It comes up with the smartest possible plan to get the job done. Then, it splits the work into hundreds of tiny tasks and sends them out to an army of compute nodes. Each of those nodes works on its own little piece of the data all at the same time. That parallel attack is how they can tear through terabytes of data so fast.
But the real magic, the secret sauce, is columnar storage. See, traditional databases store data in rows, so if you just want to add up all the sales, the database still has to read every single row, the customer ID, the product, the date, all of it. Columnar databases flip that completely. They store all the data for one column together. So if your query is just sum sales amount, the database literally only reads the sales amount column and ignores everything else. It skips over massive amounts of data it doesn't need. This was the game-changing innovation that made modern analytics possible.
Okay, so we've looked at the old rules, we've seen the new tech, and we've checked out the surprising results. Let's bring it all together and figure out what this actually means for you, the person who has to build and use these systems.
If you take only one thing away from this, let it be this. The old dogmatic rules about data modeling are officially out of date. The idea that there is one best schema for every situation is dead. The sheer power of these new cloud platforms has completely changed the equation.
So, what are the new rules? Well, Rule 1, the best choice is completely dependent on your database. What works for Redshift might not work for single store. Rule 2, stop assuming joins are always the performance killer. These columnar engines are wicked fast at them. Rule 3, don't be scared to try a flat, denormalized table, but you absolutely have to test it and benchmark it with your own queries. And finally, trust your database's query optimizer. The engineers behind these systems have spent years making them smarter than any of us at finding the fastest path to an answer.
And that kind of leads to a final, pretty wild question. We've seen technology totally flip our assumptions on their head once. So as these query optimizers get even smarter, maybe even powered by AI, are we heading towards a future where schema design just doesn't matter anymore? A future where we can just throw raw data at a database and it figures out the most efficient way to query it in real time? It's a crazy thought, but that might just be where this great data warehouse debate is headed next.